Yes, good afternoon, everyone. I, Srinivas Sharma, Assistant Professor of Chemistry, MBSR Engineering College, extend a hearty welcome to all of you for another session of the induction program, Akshay Urja. I am very happy to introduce Dr. G. Srinivas Sharma Garu, an eminent speaker who is going to deliver a lecture on ancient science and technology in India, which enhances your knowledge on renewable energy resources. Welcome, Dr. Sharma, sir. Before the start of the session, let me tell you a brief profile of Dr. G. Srinivas Sharma Garu. Dr. G. Srinivas Sharma was graduated from Bapatla Engineering College in Mechanical Engineering, post-graduated from College of Engineering Anantapur with a specialization in heat power, and obtained PhD from Osmania University in the area of biomass gasification, gas turbine technologies. He has total of 27 years of experience in teaching and industrial. His areas of interest are combustion, gasification, applicable to thermal systems. He has total of 18 journal papers and attended 15 conferences. His specific areas of research progress is gas turbines. He was awarded 3 times Best Teacher Award by Maturi Education and Charitable Trust and awarded all-time Best Teacher Award by Maturi Education Society. He was awarded Best Teacher Award for the year 2014-15 by Cognizant Technology Solutions and also obtained Best Paper Award at NIT Roorkela. His areas of solving partial difference equations of higher order for fluid and heat transport mechanism are published in reputed journal. He plays cricket and presently holds the administrative positions of ISO Chief Coordinator and College Sports Committee Chairman. We welcome you, sir. I request you to start the session.
Thank you very much, Farishan. That was very big fat introduction of me. But as on now, I am one among the best teachers. Let me first congratulate all the students, those who have opted for MESR Engineering College. And this particular session will try to see to it it's more lively. And I'll be presenting on a topic of harnessing renewable energy for future energy needs. Now, this particular topic requires a initial preamble of introductions. So I'll start with my presentation. Harnessing renewable energy for future energy needs. The title itself is telling that you have to be like a farmer, an engineer doing farming in energy sector to take what we have, give it back to our next generations. Now, if you look at one particular point, I have some observations to talk. What is the need? What is the future demand? How we are utilizing now? How best we can utilize in next coming decades? What as students and teachers we can contribute to renewable energy? We have a small oath and we'll try to conclude it because this particular session is for one particular hour and I'll be there with you for next coming around 1500 days, maybe four years and so. So we will, what best we can do, we'll try to go ahead and try to do it. Now, what's the proof that global warming is taking place? Many of them, this is the biggest buzz I've seen around the world that, people say there's a climate change. People say that, there's a global warming. There's a lot of disaster that's happening to the world. And people will always ask, is there any proof of tofu? And if you just look back at some of the things that what we collected from newspapers, I am a environmentalist and environmental enthusiast who always looks for two particular news in newspapers. One is on climate, the other one is on sports. So if you just look at it, this was very recent news that was being published in NASA when, December 3rd, 2020, if you just look at it, they say that noise and light pollution from humans alter bird reproduction, and this is very bad. We are trying to stop the biological cycle, and I have seen in Hyderabad very recent. I was talking to some of my friends, those who are zoologists. They say that the number of sparrows that you see in Hyderabad are very, very less. There's a reason. The reason is it is because of noise and light pollutions that humans are altering the bird reproduction. And if you are looking at Arctic and Antarctic zones, generally they are colored white. Maybe 20, 30 long years back, or 40, 50 long years, or 5 decades back. If you want to show in your geographical map, then you don't, paint with green rather, because you don't find any vegetation over there. But the September 28, 2020 recent news is saying that Arctic summers are warm. Northern landscape changes, and you are seeing that it is green. And you're also observing that the landscape of these aquatic animals that are living in this Arctic and Antarctic zones are changing. And this is one very alarming news that was being put up on September 17, 2020 by NASA, saying that emissions could add 15 inches to sea level. By 2100, NASA led study finds it. And so this is what, you go with the time series analysis, you go with the regression, and then you estimate it. And then finally you say that today these are the levels, and next coming years, what will happen? I tell you, my dear friends, this is causing a lot of concern. And people who ask us, what is the proof? What is the proof? And the proof is enough. Seeing is believing. It's not hearing. It's not, animated across, but it is, naturally observed. It's taken up naturally live, and then it is observed that something is really happening to this particular world. And yes, what happens? What happens? If you observe it, many of them have a misconception about the temperature of the earth. And then people say that temperature of earth is increasing 3 degrees, 4 degrees. No. From last 150 years, the average temperature of earth has increased more than 3/4 of a degree. That means it's 0.75 degrees centigrade. It has increased. It has not yet increased by 1 degree centigrade. It is completely fluctuating. Now, you may question, what happens? If it increases by more than 4 degrees centigrade, all glaciers would be gone. You don't find any ice. You don't find any river. Everything is gone. And this is happening soon. And we are always answerable. We are accountable. As a responsible citizen, we are answerable to this particular question. Are we contributing anything to this, increase in temperature of the earth? And the data suggests it. There is one particular aspect we have to look at it. Like NASA, National Aeronautics and Space Administration, we also have National Ocean and Atmospheric Administration, which is also run by the US government. And what they do is they map the temperatures all around the world, how temperature is varying, and where you are having higher ranges of temperatures and why the temperatures are increasing. You can find all that particular information at this particular website, National Ocean and Atmospheric Administration, wherein if you observe the color map, the one which is showing you the red is giving you the increase in temperature. And you are observing nowhere any blue map. That means you are not observing any cold climates. Rather, we are coming out into two particular regions wherein you are observing, only hot as well as hotter. My friend stays in Middle East, and whenever I try to talk to him, he says, they have 2 seasons, it seems. And he asked me, guess what are the 2 seasons? Now, as a person living back in India, I said, yeah, you may be having, 2 seasons. One may be summer and other one is winter. Immediately he said, no, Sharma, you're wrong. We have only 2 particular seasons. One is hotter, other one is hottest. So the mindset of the people has been changing with respect to their living conditions. And I'm for sure people will forget about the types of seasons and they will try to live in this particular world of hot, hotter as well as hottest. and we have to be very careful, whenever you try to deal. And there are, severe, cyclones coming back in Bay of Bengal, Arabian Sea, North China Sea, and you have lot in Pacific. Pacific is unexplored till now. Atlantic. And people were looking at it, scientists were looking at it, environmentalists were looking at it. What's happening? There is something really wrong, very serious. You are observing that the existence of few particular aquatic species are going out from the earth, and you can't get them back. That's one point. Second point is you are not finding any glaciers. The third point is the temperature of the earth is increasing. It is increasing, and increasing. It's not decreasing and you can't do it. And in this world, there is a concept known as entropy. And entropy always increases. Increase in entropy talks about irreversibilities. And more the increase in entropy, more the process becomes irreversible. This is what our thermodynamics say. And thermodynamics is not just confined to physics. Thermodynamics is confined to complete living. And this increasing entropy concepts, people are worried. What the mistakes we have done, looking from the concept of industrialization. If you look at industrialization, Industry 1.0 has given you steam engines. We have removed human manpower, and then we came back to steam mechanized. Industry 2.0 is your Second World War time, where you started optimizing things, where you started semi-automation, or rather than semi-automation, it is not just only on steam-based for living. It is based on complete oil-based machinery for your defense purposes and sustainability. Then Industry 3.0 have started somewhere back in 70s odd, semiconductor revolutions, what we call. And in the process of semiconductor revolution, you came across a huge shift from the complete mechanical systems to analog and digital electronics. Where it is not, I don't call them as smart. Rather you are trying to make manual to semi-automatic, then you made it automatic. Then, as you are well aware, 2000 has brought the complete revolution of Industry 4.0, wherein the computers have taken up, it's a digital technology, have taken up the complete shift of all systems. Now, everything is controlled basically by your digital systems. And then, then started this 2020, not just Corona, you have Industry 5.0. This is where your artificial intelligence, smart things, smart materials, smart devices, cyber physical systems, artificial intelligence, machine learning, all these things have just surpassed Industry 1.0 to Industry 5.0. And mind you, all this is causing the increase in entropy, and it's spoiling the environment. So if you just look out, just browse through this information, you will know it. And people will, there are observations. This is what I was talking. 1921 photograph of Himalayan glacier. These are all, authenticated photographs from a known website, wherein environmentalists and energy enthusiasts, they try to share. 1921, this is what Himalayan glacier is, completely, filled with snow. And then you observe the thickness of the snow is small, and then it's pure, loomed in white, like cotton. Whereas in 2008, you can see that the glaciers are melting. And it's not like somebody just go and put some heater over there and then doing it. No, we are doing it all that. No, it's not at one particular place. It's all around is causing the glaciers to melt. 2008, this is disaster. I believe 2050 people can trek across Himalayas just on mountains without any amount of ice. And this happens. This is Great Himalayan Glacier, known to be the most ferocious, most adventurous, unconquered, but for sure, down the years, people may just go and, keep one particular flag of their own or the country. And then every day you find, tourists in that particular place because, the glaciers have melted. It has become easy for human to move rather than, sky. This is happening. And rivers of ice run dry. My dear friends, Government of India, 15 years back, there is one particular board, Central Board of Irrigation and Power, have started one particular study on River Ganga, River Ganges project. You may be knowing it. River Ganga, it took its birthplace in the adobe of Himalayas and then passed through the various names like Mandakini, Jahnavi. Finally, when it lands at Haridwar, it's called Ganga and odd. And this has highest amount of discharge of water known to any river than in this world. People claim Amazon, but I know I have done some statistical studies, and this is Ganga is a very big river, and people, the scientists sitting there, started making an estimate like down the line if the pollution levels are so. Another 15-20 years, River Ganga will flood once, only it will flood once. Again, you won't find any water source. And this is tragedy. And, it's only like you will see in one particular photograph that between this particular, mountain cliffs in this particular valley, you used to have, water, and now you don't have so. Off the records, I can say Galvan Valley earlier was, completely filled with water. And then you had your own territorial boundaries between India as well as China. But now the Galvan Valley had the effect of your, global warming. And then the rivers, whatever the water that you had it over there, it has subsided. Because of subsiding, people could see land and people run for land. And that is how we have an issue of territorial boundary at Doklam, at another particular points of, strategic defense, things between India and China boundary. I expect again water come back and take the armies back at their regular post. Then coming back, why is global warming happening? What would be the reason for the happening of this global warming? Now, if you come back, as a student of chemistry, everybody would be knowing about fuels. Fuel is one which, when we burn it or when we subject it to combustion, it releases energy. This is a exothermal chemical reaction where every fuel is a hydrocarbon. The carbon hydrogen percentage deals whether it is solid fuel, whether it's a liquid fuel, or whether it's a gaseous fuel. So whenever you take any fuel and then it is subjected to combustion is complete burning up of the fuel in the presence of air or oxygen, it releases because the carbon reacts with oxygen, forms carbon dioxide. Hydrogen present in the fuel reacts with oxygen, forms water, it takes the heat of exothermic reaction, it becomes steam. So you say carbon dioxide as well as steam and releases enormous amount of energy. And then we will catch this particular energy and then use it for other particular purposes like generation of steam for power plants, or we use it in internal combustion engines to obtain the mechanical movement and then run piston and roll it, or you use for other utility purposes and all. So one particular cause is burning of the fuel, right? But again, where do you get this particular fuel? You get all this particular fuel from Mother Earth. No other thing in this world is called Mother, apart from our own Mother as well as the Mother Earth. So if you look at Mother Earth, it gives all fuels. You talk about coal, the solid fuel, it is mined. You talk about natural gas, it is drilled. You drill down the seashore, go down deep into undersea waters, international waters, and then you locate that there is oil, and then keep your rig, drill it, and take out oil. In the process of drilling, first you will get gas, and this particular gas is natural gas. Natural gas is methane, and methane is 70%, remaining 30% is carbon dioxide. and then you get oil. This oil is a crude oil. And then these particular fuels are the fuels which we are using as of now for our strategic development, sustainable development. There is one particular point which I want to tell you. If you look at per capita energy consumption of an average Indian, every Indian for a family of 4 have an average consumption of 500 watts, 0.5 kilowatts. This is the statistical study from MOSPI as well as from Department of Statistics, Government of India. MOSPI is Ministry of Statistics and Public Information. You can also look at MOSPI website, MOSPI, and then take information. And when you take information on an average all around the India, all the particular states spread over for 100 crore population, you observe that our average energy consumption is 0.5 kilowatts. Whereas if you look at a country like Japan, Japan has per capita energy consumption of 5 kilowatt for an average family of 4, wherein the size of Japan is maybe 1 by 20th or 1 by 20th, 25th of 1/4 of the area of India, or still less, I believe so. But if you look at their industrialization, their growth, all these things, the index is their energy consumption. This is one particular point as an engineer, whichever engineer you're an engineer. If you're a computer science engineer, if you're an electronics chap, if you're an electrical engineer, you're a mechanical guy, or a civil engineer, or automobile engineer, one particular point an engineer should think is the growth prospect of any economy is dependent on the amount of energy consumption and energy generation. So more the energy that you try to generate and you try to consume, you're using more and more amount of fuels. So what will happen when you are using more and more amount of fuel? See, I was telling you, basis, you learn chemistry, you learn everything. This is what I have learned over my 40, 50 years of my education. If you look at any fuel, it has carbon, it has hydrogen, and it can never be carbon and hydrogen. It has sulfur, it has nascent oxygen and odd. This sulfur reacts with oxygen in your combustion process, gives sulfur dioxide. Nitrogen present in atmosphere is inert up to 1600 Kelvin, maybe around 1273 degrees centigrade. The nitrogen is chemically inert. But when you cross this 1600 Kelvin, because when you want to go for high range missiles, or when you want to go for an aircraft which carry at least 100 tons, and increase the capacity, why only 180? Why only 180? It can be more, or why just 500? It can be 1,000 passengers, commercial freights and all. If you are looking at it, you require higher capacity of gas turbines. And this particular gas turbine, maximum temperature may be around 2,200, 2,300 Kelvin. When you cross that 1600 Kelvin combustion temperature, or you call it as adiabatic flame temperatures, AFT, you observe that nitrogen is no longer chemically inert. It tries to react with oxygen. When it tries to react with oxygen, NO2, NO3, you call it as NOx. X is a generic one. You can give 2, you can give 3 nitrous oxides. And the moment these nitrous oxides are released into the atmosphere, maybe parts per million, maybe concentrations may be very, very less, and you try to add up this SOx. SOx is oxides of sulfur. NOx is oxides of nitrogen. All these nitrous compounds and sulfur compounds into the atmosphere, finally, when they react with oxygen and other chemical reactions that happen in the atmosphere, down the line for next 50 years will form nitrous oxides will form HNO3, nitric acid, and sulfur oxides will try to form H2SO4, sulfuric acid. And one particular point of time, if rain falls, people will run away saying that it could be an acid rain. And it happens. So if you go with the same, growth rates and odd. So, my dear students, you should be very careful whenever you are trying to take any particular appliances where it gives any pollution. Try to take one particular thing like it should have proper pollution emission standards. Now, how is global warming measured? People say, okay, this is fine. How do you want to measure, Sharma? I would say like carbon dioxide levels. You cannot take a thermometer all around this particular world and run. There are so many locations, infinite amount of data, and you can't process it. There's no point talking from standpoint of, your temperature. So the other alternate that we'll try to do is global atmospheric concentration of carbon dioxide will try to decide your, global warming phenomena. 1870s, that's 100 years back. When I was born somewhere in 1970. 100 years back, the carbon dioxide levels were around 280 to 300 parts per million. And if you observe it from last 150 years, this is the stats go from here 2000 and then add 20 more. This is going exponentially. This exponential growth, this is your industry 1.0, industry 2.0, somewhere around 1940s. This is industry 3.0, this is industry 4.0, and industry 5.0. We are there. And this is how you have to measure. Then again, question comes, how do you measure carbon dioxide levels pertaining to 1870s? Yeah, there is a possibility. This is fantastic physics. We should always see to it. We should read more and more of our basic physics that will help us to determine better things in coming years. Now, there is one particular data known as ice core data. I've seen people from various countries, they go for Arctic and Antarctic explorations. They have their own space stations. It's not only for defense purpose. You gather a lot of data. You contribute a lot to this particular society. Who knows? Down the line, any one of you from this particular batch of 2020 would land up, doing this particular job. What we will do is we will try to take ice core. Ice cores are cylinders of ice drilled out of an ice sheet or a glacier. Most ice core record come from Antarctica and Greenland. Greenland is northern part of your Canada, and the longest ice cores extend to 3 kilometers in depth. So the oldest continuous ice core records to date extends to 1,23,000 years. My God. I can go back into the past if I'm really good in my physics, and I'm for sure the physics department at MBSR Engineering College is the best to guide you the things. In Greenland and 8 lakh years in Antarctica. What we do, ice is, it's a gradual formation. It's a heat transfer phenomenon. When outside air temperature drops because of the seasonal winds, whatever the water that is there, when the temperature is below its freezing point, you observe that freezing starts. And in the process of freezing, the amount of air that is present in the atmosphere gets entrapped. If you want, do this experiment at your home. Keep a bowl in your fridge, pour some amount of water, and then simply, freeze it. Next day morning, take out that ice drop, and in between you see that there are, air bubbles. Bubbles are nothing but encapsulation of the gas in this particular, solid. So it is solid gaseous mediums generally what we will do. So this particular ice core would have encapsulated the sample of air, thousands of years back, and then you take into the laboratory and then analyze that particular air data. You will get the carbon dioxide component. And again, you ask me, that will be in 1 or 2 mm diameter would be the spherical capsule of the air. How do you do it? There are chromatographs. You can use in a spectrum chromatography, optical science. In physics, you talk about optics, and in mechanical engineering, we use this particular optics for measurements, micro level, nano level. Things have been done. So what you do is, you just take it to the lab and then analyze this particular the air bubbles encapsulated in your eyes. You will be directly getting, carbon dioxide concentrations. More the carbon dioxide concentrations, mind you, you are warming the air. That is what it says. So this is your Latum Antarctica ice cores. 1,000 years of carbon dioxide data has been given. Right from this, we call it as air age, because you're going with analysis of that air bubbles for carbon dioxide concentrations. So this is how you will try to measure. So somebody coming and asking an engineer that how do you measure the global warming and not any layman. So don't just take a small excuse. I'm sorry, I'm a electronic guy. I don't know about this. This is responsibility of every engineer, every engineering student to learn. And just give an answer like you take an ice core, take the air bubble data, from that measure carbon dioxide, and then try to say that this is how it goes. Now, one bugging point, every day I see newspaper. I see every day, I'm telling you, I am a very good statistician on newspapers. I collect data for my own good, for my own interest, and for people who care for this particular information. Every day I see news that Delhi is having a biggest issue with air quality index. Yes, that's correct. Air quality index can be measured in India with AQI, air quality index in India. This is the website wherein you can see what is the air quality. Today morning I measured at Hyderabad while coming back. I didn't give the precise location in our campus, but I'm sure in our campus we are at around 73 air quality. We have a wonderful campus, lush green, and it is warm, wonderful air. So in Hyderabad, you have around 96 parts per million is your air quality pollutants. You have it. Whereas you go to New Delhi, it is 393. Alarming. It is damn hazardous. People suffering from bronchial asthmas or any amount of RTI, respiratory tract infections. Delhi environment is severe. So many other parameters are playing it. But all for same, I wish Delhi should come back to the level of Hyderabad. Chennai is now running at around 24 today. Mumbai is at 135. Hyderabad is at 96. This is what we are at moderate, and we have to be very careful. It is not just temperature, it is also air quality. Say suppose you are in cool climate around 28, we call it as human comfort temperature should be around 24 plus or minus 2 degrees centigrade would give you human comfort. This is what World Health Organization says. But apart from that, air quality is one more parameter. The soot as well as the other insoluble parameters which are governed by mass diffusions should be kept in control. And I wish that Hyderabad will come back to its normal, should not be in moderate. We should get it back to normal things. So why we are talking about this particular topics? There is a lot of energy depletion. There is environmental pollution. There is increasing energy demand, and we are a developing country. Yeah, this is what I was hearing right from my childhood. We are still in developing country. We are not yet developed country. I told you earlier the index of developed countries. We are looking for clean energy. We are looking for carbon trading and all. So if you look at future global energy demand, my dear friends, look at next 3 slides, you will understand where we are standing in. See, this is 2010. In 2010, our oil is around 33.6% more than what we want. And we are trying to 2040, we are trying to decrease this. We are going with coal. We are trying to decrease these 2 fossils. We are looking at natural gas. We are trying to increase natural gas. We are going with more amount of renewables. We started with around 9.5, and then at around 10.7 we were at 2010, and then we were somewhere here 2020 exactly midline if you try to draw. No, we were somewhere around 12.5%, and then nuclear 7.7% is a higher end for India. We have not yet tapped not even 1% of the total energy consumption in Indian scenario. So day to day, there is an increase in the global energy demand. Why? Everybody want to become developed. There are only 7 countries in this world which you call as developed countries, and you call them G7 group. India is not yet in this particular G7 group, and we are trying to take this particular place into it, and that is only by our energy production, energy demand, our industrialization, and so. And India's energy demand is increasing. Our energy demand as on now, our demand is this equivalent in terms of metric oil tons. So if you come back and see in 2040, it is 333% increase. I'm telling you, we were somewhere here now. And if you are looking at it, we are already at around 150% increase. And maybe 200% or 225% or 250% here in 2030, and 2040 it is 333%. And from where can we compensate it? From where can we get all this? How to do it? And then it is all on fuel, and it is only obtained from the Mother Earth. And our industrializations, our scopes, our future economy. People say, I want to go into a 3 trillion economy. I'm not with any political party, don't take me wrong. I'm a simple teacher, I'm for my students, and I'm just giving information. Around the world, I hear this particular buzz saying that we want to go for 3 trillion economy. Now, is it possible without scope of energy? Yeah, it is. It will not be if you don't go ahead with your energy demands. And this is one particular slide which always tells me, be careful, Sharma, this is what it is happening. I always tell to myself, like, yeah, I should tell to my students, this is very important. As our growth energy demand is increasing, we have to excavate, and then we have to increase our annual production growth rate of energy. And if you are going with it here, with the same growth rate, what we are having as of now is 0. And if I'm going with same growth rate, maybe this green line is indicating oil. Oil will get out after 2050 or 2055. Whatever energy resources we have it as of now in this particular world, with the same annual production growth rate of excavation of these fuels, 2055, my dear friends, listen carefully, 2055, oil is gone. And for sure, my grandchildren will question me, Grandpa, you used to work on diesel engines and petrol engines. Tell me what is diesel and petrol. I'm telling you, one day, diesel and petrol will go into museums, and they will show you this is earlier liquid which people earlier used to run their vehicles. Their livelihood used to be on this, their transport mechanisms. Suppose if I'm going with 1%, if I increased 1% more, it would be 2045. And if I'm going with somewhere around 7.5% annual growth rate, that means I increase my production, oil production and art, gone. 2035, this is gone. This is what automobile sector has realized. And then they said, no. When suddenly oil goes out, I don't have any car to run. It is my Nano, Tata Nano, wonderful and marvelous vehicle at low cost. And BMW, both will stand on the same road, useless, and you can sell them for more price, but people will take Nano because it is compact and you can, crush it into metal within no time, whereas BMW takes more space and it's of more weight. That is how, people are looking at it. So oil would be gone. 2070, natural gas is gone. And 2130, you observe coal is gone. Coal, we can depend for some more amount of time. And this is alarming. I have industrializations. I want more growth. I want more fuel. And then everything is going out because it's all fossil. It's all made some 1 lakh years back. And if I'm going with same annual demand, same amount of energy production rates, you will not find Earth to be green except on some Hussein's painting, or if I start painting it, thinking about me and the greenery which I have seen it earlier days, I would paint some green color, but you would see all this. This is industrial estate. I have seen one particular industrial estate with, brick plains and odd in and around Surat. While I was moving between Mumbai to Surat on one industrial trip, I could take this photograph because Mumbai is industrially developed, Surat is industrially developed. Mumbai and Surat, both of them are now connected with a diamond highway corridor where people were planning to, give this bullet train connectivity. All this is fine, but in the suburbs, you observe all this trash, all this particular trash. These are the condensers, cooling plants of power plants, throwing away huge, enormous quantity of steam into the atmosphere. And you don't find only just, steam, there will be some amount of soot. And this is one particular backyard of a wonderful hotel in Mumbai, wherein you have enormous amount of plastic residues. And I don't want to see such, landscapes. I want to see beautiful green lung spaces, lush green spaces to be there. And this is all caused only because of global energy demand. And we are spoiling everything. Yeah, this is one particular cartoon. I took it from New York Times. In New York Times, daily you observe one particular cartoon on energy, climate change and all. People talk about clean energy and then say that it is code green. Told this technology is clean. Yeah, people say it cleaned up the whole area. Wonderful. You love it. Engineers, you have to think this is social conscious cartoons which will tell to people, which will educate people who are not engineers, tell them that you be careful. And it will also educate engineers, those who are not giving proper solutions to this particular world. Then comes one particular topic. This is one topic where, business does not have any areas of their own domains. Business is everywhere, even in, trading, carbon trading, what you call it, is there in this global warming. There is one accord, some 5 years back, you have seen that there is one Paris Accord, wherein all countries from this world has met and then came to one particular agreement saying that we will try to reduce our emissions to around 20%. Around 10%. It should be 10% greenhouse gases should be reduced. Methane is the highest damageable greenhouse gas apart from carbon dioxide. It has a greenhouse gas index of 24 compared to carbon dioxide. Carbon dioxide is 1, whereas methane is 24. And if you look at it, there is a seal that you cannot release the greenhouse emissions more than 10% of the world energy standards. Then I have two particular companies in this particular world. One is based in America, other one is based in India. And one which is based in America have more orders. So it cannot stop less than 10%. What it will say, I will go up to 15%. Whereas the company in India does not have much amount of orders to realize. So what it will say is, like, you wait, I will try to reduce my emissions from 10 to 5 only. Whatever 5 you have it, that 5 I will transfer it to you. In the process of it, you pay me. And this is absolute nonsense. I'm telling you, people are spoiling it. People are really spoiling, going on carbon trading. Asia Carbon Trading is the biggest company that's made, millions of dollars, seeing to it, keeping a cap on industrialization in India. I'm telling you, Indian industrialization have been kept an access, or you can say a supersede limitation because of this carbon trading. So the one who is in far west will emit more amount of gases, and in India we will emit less amount of gas. That means our industrialization will go down. And for this, he will pay us back. There is one country in this particular world. I tell you again, there is one country in this world by name Netherlands. And the name is very odd. If you observe it, name is very odd. It is neither land nor sea. That's why it is called Netherland. And this particular Netherland develops all technologies based on energy consciousness, environment consciousness, because it is 1 inch below sea level. And if you observe that any quantity of rise in the levels of oceans, will see to it there is no Netherland on the map. So this country comes down and it makes this brokerage, licensing between countries in carbon trading, and in the process of it, industrialization is going down for few countries where they are still in the developed stage. So you want industrialization, you have to increase your emissions, and then you have to look for other alternate countries. Like nowadays, people are on African countries, and they are saying that you reduce your emissions, we will increase our emissions. In the process of it, we'll pay you back. This is what people were doing. It's all economy. I'm telling you, finally, economics will finally, administer, govern the laws. It's not we. It's only the economists deal the things. They rule the world. And this is the mind of economists. Think how economist is coming back and leading the business between countries in the growth of industrializations and keeping a ban. Now, in India, if you look at it, we are not yet 10% overall installed capacity of renewable energies. If you look at it in India, we are with solar, we are with small hydro, we are with biomass, we are with bagasse generations. Again, bagasse comes back into the biomass gasification or aerobics. Then we are into wind. We are tapping more amount of wind nowadays. This is very exciting to see the Indian scenario. How we are using in all these scenarios. We are using in active mode, we are using in passive, we are using wind, we are using biomass, we are using tidal. We don't have natural ports, only France has a natural port for tidal power things, and OTEC, Ocean Technology Energy Conversion, Ocean Thermal Energy Conversion, geothermal, micro, mini, small hydropower plants. This is slightly questionable. That's why I kept an exclamation mark over there. Some people say it is not renewable, some say renewable, but I say renewable or not, use any small water resource, conserve water, do it. Now, this is solar energy. You have a solar photovoltaic cells. Solar photovoltaic cells work on your principle of your thermal effect, and you have learned whenever there is incidence of light emission on this semiconductor materials, they get excited. If the frequency is more than the threshold frequency, then you have free electrons, and these free electrons, when captured across the circuit, will give you current. And this photoelectric effect, which was given by your Einstein, Sir Albert Einstein, has got a Nobel Prize only for photoelectric effect rather than delta E equal to delta MC square, because that is spoiling a lot of damage to the environment, whereas this is causing a lot of humankind, energy consciousness, and whatever the photoelectric effect that was being drafted some 70, 80 years back, we are using it now. You have your solar photovoltaic cells for electric generation, and those we use it for electric generation. We call it as active. Now, passive is taking heat. Nowadays, government of India is supporting the farmers in pumping. 90% subsidy government of India is giving. I'm telling you, you promote, you tell to any farmer who comes back to your aid, ask him to stop the concept of this particular free power or free things. Help him as an engineer. Give him a design. At least if you can't give monitoring, give him a design. Tell him, educate him, so that he will continue his farming and next generations will have food to eat. This is one particular very exciting project given by Government of India. 15 years back, I believe, when Government of India had given their National Energy Mission, India was lit only 65%. 65% India was lit. That means rural electrification was absent. You don't observe any amount of electrification in some areas. I have seen an area near Rajahmundry. From Rajahmundry, you go towards Araku and Odd. That is one particular, we call it as Andhra Orissa border and Odd. There are some villages which don't know about electrical light. They still rely on old, candle wicks and other lighting. Then one Satyasai Seva Samiti along with Government of India took an initiative. They made this particular solar lantern. I'm telling you, come back to college and make this. It should not be your final year project. It should be something like your first year project. You take a photovoltaic cell, connect it across, keep a small battery, and you can find it battery in your bike. Just take a battery from your bike, connect it, and then charge your battery. Give an LED, light emitting diodes. Light emitting diode, 1 watt, is equivalent to 10 watts of regular bulb, incandescent bulb and all. You can calculate luminance and all. Come back to me or physics department, they'll help you about the calculations and all. And then finally, you can make this particular lantern. You can make one particular lantern in your home. Keep it for your reading purpose and all. I tell you, Government of India has distributed 1 lakh, more than 1 lakh of solar lanterns across. Even at terrains like Ladakh and Odd, it went for captive power generation, solar. We went with rural electrification project. Now India is 90%. It is 90% electrified. And don't just misunderstand. Solar energy is only for electrification and all. This is one project which Japanese were using wherein I don't know. I'm still surprised with their thought process. I'm still surprised with their thoughts as well as the way these people think. They were transferring the solar energy that is available from the atmosphere, outside atmosphere, space, onto the earth through electromagnetic signals. And one day we will see no power plants on earth. Maybe all power plants will be shifted onto the space. Lucky indications for India, because our ISRO is very strong competitor for other global space agencies. So that will be something like a transporting agency for all these power plants to go into the space. That's what it should happen coming years, and you should all be a part of this particular project. Then wind. I've seen many of them talking about wind. I've seen many of my students coming back and asking me, sir, why don't we keep one particular windmill at MBSR Engineering College and do it? Yeah, you can do it. But initially going for it, you should look at, the wind map. These red zones are the zones where you have the wind capacity and odd. If you are going towards Thiruvananthapuram and odd, you will find a wind farm. And this is other part of Bangalore. And if you are going towards this Anantapur, or if you're going from Hyderabad to Bangalore highway, after you cross Anantapur, this is this particular region where I'm showing my cursor and all. This is one region where you can tap. Gujarat, many of them say, Gujarat, you see windmills. In Hyderabad, you don't see windmills. Gujarat is having the natural resource of wind. Wind velocities are higher. And you cannot keep all those installations in this wide regions. So some states are blessed. Thanks that, Gujarat, in and around Mumbai, you have the northern part of Karnataka, southern part of Maharashtra, then eastern part, the western part of Andhra Pradesh. Telangana does not have. We have this wind potentials. And we go with the horizontal. That's why when you visit Tirumala Hills, you see, horizontal axis turbines mounted on Sahyadri Hills. And these are vertical axis turbines. I have seen this particular design. This is wonderful design, which I have seen in one of the airports at London. London has a Heathrow Airport, because at airport, you have so much amount of tourists coming, and it gives you the international value. Hence, what they did is they have not kept something like this. They have just gone with the aesthetic design, and this is very tedious in calculation of the aerofoil profiles and what. So they have added some architectural values to this particular turbines, and they were using it. And this particular turbine was developed by one of the students at Purdue University, their energy division. We will also do it at MESR this particular year. I promise if any of the enthusiast students come forward, we'll do this at MESR. It's a balloon. And balloon, you can fly anywhere. And in between this particular balloon, they have kept one particular mast, the rotor. And then this does not require any mast, does not require any installation. It's like flying a kite. And the thread is nothing but a wire. Send it to any height, because the height velocity of air is inversely proportional, directly proportional to cubed power of height. More the height you go, the velocity is more. So just fly a kite. So now in coming years, we may see this airborne, you call this as wind turbine, and then you tap power. There are lot of things coming across. And this is biomass gasification, and one who is want to take one wonderful career in chemistry and odd with thermochemical reactions and odd, you can use this biomass gasification. What we will do is we will take solid fuel, convert into gas. There's no liquid phase. Combustion is stoichiometric. Stoichiometric is chemically correct oxygen. You give it air. Whereas you go with anaerobic, that means you starve it with carbon, the amount of oxygen. So you'll not getting carbon dioxide, you'll be getting carbon monoxide. This carbon monoxide along with hydrogen is a wonderful fuel. And we have a biomass gasifier, downdraft gasifier installed in our college. All these efforts goes to the Department of Mechanical Engineering. And you can convert coal. Prime Minister, in his budget address, please think, in his budget address, have said that we are going with coal gasification. Enormous quantity of coal is there. So coal combustion technologies will be, not be as reliable as we are looking at it. So coal gasification technologies will give you carbon monoxides as well as hydrogen, which people call it as producer gas, people call it as syngas, people call it as water gas. That depends upon the process and procedures in which you come across and then take it out. So in MESR, we are trying to take municipal solid waste. We are writing proposal to Government of India. We want to take municipal solid waste. Huge amount of trash is there. And we want to convert this municipal solid waste into gas and run it engines for power production. Then comes biogas plants. India has a population of 100 crore, and you have enormous quantity of night soil, sewage. You have enormous quantity of cow dung, enormous quantity of poultry waste, poultry litter, what we call. And don't feel like it's ugly. This is where we don't want to process it and all. Germany has come back to Rajahmundry, one particular place in Rajahmundry, because this West Godavari is hub of the poultry production and all that poultry litter they are using in this huge cans, which you call it as the biogas plant. We had 1960s in our national planning. We have earlier planning commission and all. Even now also we have it. And in planning commission, we went with Dinabandhu biogas plant, wherein you don't do anything. Take this cow dung, mix it with water in equal proportions, put it in one particular vessel. Don't do it at home because it is slightly anaerobic, and after gas is obtained, that particular tank, if no volume is there, it will blast. Come back to college, we will do all these things. Very exciting careers. You can have it here at MESR. So you just put it, there is methanation reaction, there are methogens. Methogens are biological organisms. What they do is they eat away all this particular sludge, release methane. And this particular methane is, highest calorific value gas. And it has around 24 megajoule per kg. And this particular gas, you just take it out, and that goes for your cooking purposes. And whatever the sludge you have it is highly rich in nitrogen. And this is natural first fertilizer. And this natural fertilizer, you put it in the farms, you will get organic food. No, need not go for only organic farming. This is how people were doing. This bottom one is the biogas plant built at IIT Delhi, Center for Energy Studies, IIT Delhi. So people are working a lot. I'm telling you, world is changing. World is no longer the same. What I have seen it, and world will be changing a lot, and you will be the root cause for all those changes. And I wish that you should come for that particular change. Then comes how best we can utilize the next coming decades. Next coming decades, I'm telling you, all the systems will be same. We'll be growing in a shrinking world. No, that means all in compact form. You will not find a very big, biogas plant. Rather, the size will be decreased by 1/3. That means you are making a compact, and that is where engineer competency is coming back. That is where your expertise, that is where your innovations should start. And miniature models with smart compatibility of remote power transfer without cables. This is one particular point where electrical engineers should concentrate. We are using a lot of cables. Whenever I talk to many of the builders who are my classmates earlier, whenever I go and talk to them, what's the problem that we are facing? They tell that everything is okay. These electrical cables, they are same. They are not changing. And they asked me, as an engineer, why don't you suggest us would not be any technology wherein, remote power transmission without cables? No. I say, as of now, I don't have any thoughts to talk. And I haven't seen anybody coming on, but cyber physical systems, the smart world has started now. The smart world would give you all those things. Then what as students and teachers can we contribute to renewable energy at home? At home, what we can do? Save energy. My dear friends, please save energy. 1 watt saved is equal to 1 watt generated. 1 penny saved is 1 penny earned. This is what I learned from Brennan Martin. And then my teachers at my school and college level used to tell me, save energy. I tell you, save energy and be careful with it. Perform energy audit at home and identify components which consume more electrical energy. This is very simple. Take the wattage, whether it is giving switch off everything at your home. Start only one particular electrical appliance. That electrical appliance should have some rating. That means it will consume, say, 10 watts. 10 watts. Then go to energy meter and then calculate whether the same 10 watts is consumed or not. If not, there is some loss. That component is useless. That is how Bureau of Energy Efficiency is giving you star rating, 3-star, 5-star, 7-star rating. And whenever you purchase electrical appliances for your home as an engineer, now you are an engineer, you join MVSR, you are an engineer. Whenever you are going and purchasing any components, just go and check energy rating. Ask them a question. Are they energy rated? What rating? You have BEE rating as well as International Energy Agency rating. Just know them. Slowly you will try to accustom yourself so that you can tell to your friends and all. Observe which components can be replaced by renewable energy components. Your geyser, immediately install it solar water heater. Don't change your high energy components like your ACs and all. But lighting, you can go with your straight solar. Or if you have any incandescent bulbs and fluorescent bulbs, replace them with LEDs. Mind you can do that. And then this is a wonderful thing. Last one, grow plants and trees more and more. Grow them because they are indicators of your environment. They absorb carbon dioxide, give back oxygen, reduce the temperatures and all. This you can do it at home. At college, what you can do, because now you will be having 2 particular homes. I bet to you all MBSRians, you love to stay more in campus than at your home. So what as students and teachers can we contribute to renewable energy at college? Switch off Fans and lights, whenever you find it is not of requirement. If you are last to leave a room, don't feel like it is a job of that maintenance fellow, it is a job of the college, I am paying it, so I'll not switch off. Don't do that. Please switch it off. This is your core responsibility. Try to understand cyber physical systems and develop intelligent components which do our job of switch off and switch on. Nowadays, I am seeing advertisements in televisions that you become more lazy switching off lights as well as tubes by your mobile. I am not suggesting this particular thing. When you walk out of that particular room, the automatic power system should switch off. There should have sensors and all. And we will see this in coming years. Develop prototypes for better tapping of solar and wind energy. This is required. Now you are learning. Your learning phase starts with doing things in very, very amicable way. Learn this as a habit. Learn this as a habit. Grow plants and trees. Grow plants and trees more and more. Then today, let's take an oath. I, Dr. G. Srinivas Sharma, hereby take the following oath that as a student, I'm still a student at MBSR because I learn a lot here. As a student of engineering, will promise on the 7th day of December 2020 that I will promote renewable energy usage in India and implement clean and good practices of saving energy. Finally, will give back the same earth to my grandchildren, which I got from my grandparents. You can reach all the informations of energy at MNRE, Ministry for New and Renewable Energies, Bureau of Energy Efficiency. Then you have Sardar Swaran Singh National Institute of Renewable Energy, Solar Energy Center, Gwalpari, Haryana. You can Google the following at Swachh Bharat Mission, Solid Waste Management Project, International Energy Associations. You can always contact me for more updates on this. You can reach me on this mail ID. It's my personal. And then I'll also give you my college ID, then my mobile number. Today, make it a day. Please plant a tree or donate it to one who definitely loves it. And it should be your mother. Please plant a tree or donate it to one who definitely loves it. Please donate one particular plant to your mother, and on her name, please plant a tree today. Thank you very much, my dear friends.
Thank you, sir. Thank you, sir. Thank you so much for your wonderful speech. And we have received many questions which are raised by the students. May I request Mr. Vamshi Kumar to disclose the questions.
Thank you so much, Sharma sir.
Thank you, Urja.
So we got many responses, out of which I picked a few of them, sir.
Okay.
So one student asked that by 2050, if we shifted to all electrical vehicles, can we reduce the pollution? Because we are not using.
Yeah, that's a wonderful question. That is where the thought process of engineers have started. See, when you are going for electric vehicles, how do you make the production? So, my dear friend, electric vehicles may reduce pollution for atmosphere, but you call it as secondary pollution. Secondary pollution is caused by going for manufacturing of these particular components. In an industry, you should go for a forge. You should go for assembly. You should make all these things, finally make a battery, and then run it with this particular batteries. And as on now, the technology is on battery technology and all. So making a battery will release pollution. So I don't find like electrical vehicles will reduce the pollution standards. It is like our consumption should reduce. In Singapore, every year, am I audible?
Yes, sir. Yes, sir. Yes, sir. You're audible, sir.
In Singapore, every year, the government will give registration of automobiles limited to 10,000. That's all. And only one particular vehicle, whether it's a two-wheeler or a four-wheeler, only one particular vehicle per family. People use public transportation. That is where government is coming into accountability. Whereas in India, why not India? You take me, I own 4 particular vehicles. So I am also not conscious. So this mindset should change. That we have to slowly shell down the consumption of the purchase of this particular vehicles. Then levels of pollution will go down and slowly shift it to electrical technology will take it. Yes, Vamsi, right?
Yes, sir. One more question, sir. India is better with the title developing country or with the title developed country? Which is better, sir?
India is a developed country in human resource. Human resources is, we are in a developed form. We are still in developing phase in industrializations. So we have excellent human resource. We can call it as developed, far developed human resource. But we are in the phase of development only because of lack in infrastructure as well as industrializations. So I can say something like we are in cyber developed country and we are industrially developing countries.
So one more question, sir.
Yes.
What is the best remedy that can be possible with our students to save our environment?
Best remedy?
Yes, sir.
Can you please repeat, sir? Repeat, sir.
What is the best remedy that can be possible with our students to save our environment?
Wonderful question. Thank you, my dear students. First time I'm coming across this particular question. What we can do is we can start one particular, not a group. It should not be a group, association, activity, and all. You can go ahead with the consciousness of creating awareness among people. All over India, 2% is the total population which is taking graduates, engineering graduates. In 2%, out of 2%, only 10% of this 2% is contributing only to energy. Irrespective whether you are, whichever engineer you are, how best if you want to improve the environment is not that you change, but you create an awareness. Among everyone. It's something like whenever you are putting up any information of your kind with anyone, keep one small tag on environment, one small tag. Something like save water. Information, we are living in a world of information, and this world of information can change. This is first point I have. Second point is, please come back to college. I have got to discuss. I'll let you know.
Yes, sir. One last question, sir. This is my personal question. So you talked about Delhi pollution in the beginning, sir. So what I feel is, mainly in the months of December and January, Delhi is more polluted because there is, in Haryana and Punjab state, all this paddy remains will be fired, sir. Okay. So what I feel is actually that farm remains should be biologically decomposed. Then there won't be any problems. I heard that if you burn 1 hectare, 2.5 acres of paddy remains, farm remains, which causes pollution, which is equals to 6,000 cars.
Okay.
So actually, yes, sir. What I feel is, India is a country of human resources, as you said. Okay. But we are more shifted to machineries than you are depend on rather than looking for human resources. So we are making people lazy, thereby we are increasing the pollution also, sir. So in a country like India with more population, if we reduce machine works and if we make people to work there, and we can reduce pollution as well as we can create a lot of employment. So that's what I feel. What do you say, sir?
Yes, sir. Actually, when you said you want to ask a question, I felt it is a difficult question. Definitely, this particular question should be answered by a policy maker rather than a simple teacher like me. But still, I will attempt. This government of India has started gasification project. That is how we were also working out. So we are planning to gasify this agricultural waste. That is one particular point, because you go with biological treatments, there are some issues with biochemical reactions. Hence, we are not looking at biochemical adversities. So we are going with thermochemical conversions. That is one point. Second point is people are changing. People are changing. Lot of people are changing. We can't make them lazy. But all for same, let us see, sir, coming years, India will be developed. And we will be a part of it. We will see huge infrastructure coming. Then let us see people coming from Japan, America, Russia, and other parts of the world come down for their livelihood in India. I wish this day should come back. Yes, sir.
Thank you, Vamshi sir, and thank you, Sharma sir. It gives me immense pleasure to propose a vote of thanks. It's our proud privilege
Sir?
to have. It's our
Sir,
proud
one
privilege.
point I want to say.
Tell me, sir.
Sir, one point I want to say, sir.
Tell me,
I would really thank Dr. G. Kankadurga Madam, Principal of MESR Engineering College, Dr. Sunita Garu, Head of the Department of English, then the Head of Department of Applied Sciences and Humanities Department, in which all these departments come, Dr. A.R. Subramanian Garu, and all others who have given me one particular opportunity to speak about Akshay Urja. Yeah, thank you, sir. Please go ahead.
Yes, sir. Thank you, sir. It's our proud privilege to have such an eminent speaker, Dr. G. Srinivas Sharma, Associate Professor, Mechanical Engineering Department, MBSR Engineering College, among us. Sir, you have spoken about the global warming and what are the causes that causes the global warming and what are the precautions that ought to be taken to prevent the global warming. And you have also explained wonderfully how the Himalayan glacier was there in 1921 and how it was there in 2008. And you have also explained about the emission standards, air quality index, and you have also wonderfully explained about the global energy demand. That means how the energy was consumed in 2010, and more than 56% of the energy is to be extra utilized when it comes to the 2040. And you have wonderfully explained about the solar energy, how the solar energy can be converted into the different types of energy by using the photovoltaic cells. Thank you, sir. Thank you for a wonderful explanation about the biogas massification and which enlightens us with your knowledge. Thank you so much, sir, for your informative and motivative speech. And I assure you that definitely just will follow your instructions to promote the renewable energy resources. Dear students,
Thank you.
Dear students, it is the time for lunch. After that, we have a session on creative arts, especially dance, by Dr. Dhanya Menon at 2 p.m. So I request you to join the session at least 5 minutes before.